All right, let's get right into it. Today, we are tackling one of the biggest, maybe the biggest challenge in AI right now. How to build systems that don't just guess, but actually know things based on your own company's data. We're going to lay out the exact blueprint for making your AI trustworthy.
So it's time to move beyond the simple chatbot. Look, any engineer who's worked with large language models knows this feeling. You hit a wall, you connect all your documents, you ask what you think is a simple question, and the answer you get back is, well, let's call it creative. Or sometimes it's just plain wrong.
And that brings up the big question, right? Why do these AIs seem to lie? The technical term is hallucination, but it's not really a moral failing. It's an architectural one. You see, we're asking these models to find a needle in a haystack of documents. And when they can't find it, their whole design, their very nature, is to just generate the most probable sounding answer. They are literally built to narrate, not to know.
This slide just perfectly nails the two paths you can take. On the left, you've got the common pitfall, the naive way. You just throw a user's question directly at an LLM with a big pile of documents. This is Retrieval Augmented Generation, or RAG, in its most basic form, and it is just loaded with guesswork. But look at the right side. This is the production correct way. Notice the difference? The question first goes to a system of facts, a knowledge graph, and its evidence. Only then does the LLM get involved, and its job is just to narrate those facts that we already validated.
This brings us to the blueprint for what I like to call a truth machine. And the core idea here, the absolute aha moment, is a radical separation of concerns. You don't ask one component to do everything. Instead, you build a system where each part has one, and only one, very specific job.
And this table here lays out that separation perfectly. First up, the knowledge graph. This is your single source of truth. It stores facts and relationships, and its only job, its only purpose, is to answer the question, what is true? That's it. Next, the vector store. This is what powers your RAG system, and it holds all the context. It answers, okay, why is it true, by pointing to the original text. And finally, you have the LLM. It's just the translator. It takes the facts and the evidence and simply answers, how can I explain all this in plain English?
This right here is the foundational rule. You have to burn this into your brain. The knowledge graph holds structured facts, things like incident INC 123 affects the payment gateway, and it holds references to where that fact came from. The text store, on the other hand, holds the messy, unstructured content itself. You never, ever, ever mix them. Storing giant blobs of text in your graph just makes it slow, bloated, and it completely defeats the whole purpose of the system.
Okay, so I think we get the what and the why now. So let's get into the how. How do we actually build this beautiful graph of facts from a giant mountain of unstructured text? Things like emails, documents, and support tickets. Well, it's a very meticulous 6-step pipeline. We start with some basic text pre-processing, just cleaning everything up. Then we use NLP for entity extraction to find all the key nouns, the services, the incidents, the people. The absolutely crucial third step is entity normalization, which we're going to talk about in a second. After that, we do relation extraction to find the verbs that connect all those nouns. Then, and this is critical, we run everything through schema validation to make sure it's high quality. Only after a fact passes that check do we move to the final step, graph construction.
Let's just pause on that third step, entity normalization, because it is so important. This process, also called canonicalization, is all about making sure that PG, payment gateway, and payment service all resolve to the exact same node in your graph. This is, without a doubt, the hardest part of the entire pipeline, and frankly, it's where most knowledge graph projects completely fall apart. If you don't have a solid normalization strategy, your graph just becomes a useless, tangled mess of duplicate nodes.
And then you have the gatekeeper, schema validation. This step is completely non-negotiable. Think of it like a bouncer at a club. Before any extracted fact, like incident affects service, is allowed into the graph, it gets checked against a predefined set of rules, your ontology. Is the relationship allowed? Are the entity types correct? Is the direction right? And here's the key, no LLM is involved here. This is pure deterministic logic. It's what guarantees the long-term integrity and, most importantly, the trustworthiness of your graph.
So we've built our trustworthy graph. Awesome. Now what? How do we actually use it? How do we ask it complex questions in a way that is both incredibly powerful and completely, totally safe? This quote is the perfect mental model for this. You see, the LLM's job is not to answer the question. Its job is just to translate the user's plain English into a structured query. The database, in our case, the graph, is what actually executes that query to find the answer.
And the ontology, our set of rules, that's the contract that makes sure the LLM generates a valid and safe query every single time. It keeps everyone honest.
So the flow looks just like this. The user asks a question in English. The LLM's only job is to translate that into a structured piece of data, like a JSON object, which we call a structured intent. It's not code, it's just a machine-readable description of what the user wants. Then, your own application code takes that safe, validated intent and executes it as a deterministic traversal on the graph. The LLM never, ever touches the graph directly.
And this slide really shows you why that separation is so critical for security and reliability. On the left, you've got the risky approach, letting an LLM generate database code like Cypher directly. Yeah, it's fast for a prototype, but it is a security nightmare. It's prone to injection attacks, hallucinated labels, and queries that just plain break. The safe, production-grade pattern is the structured intent on the right. The LLM generates data, which you can fully validate. It's deterministic, it's easy to debug, and it is completely safe.
Okay, wow, we've covered a lot of ground. So let's bring it all home. Let's distill everything we've just learned into a few memorable, actionable rules that you can take away and start using right now.
If you remember only one single thing from this entire explainer, please make it this. The knowledge graph is the truth. The RAG system provides the textual evidence for that truth, and the large language model is simply the narrator that weaves them both together into an answer a human can understand. This separation of concerns, it's everything.
And here's the second key principle to remember. The journey really matters. NLP extraction, that's just the first step. It creates candidate facts, but it's that schema validation step that's what creates trust in those facts. And only when you assemble all those trusted facts into a graph do you unlock the real power of multi-hop reasoning and deep analysis. So don't stop at just extraction.
And finally, here is a super practical checklist of what not to do. These are the anti-patterns. First, never let the LLM decide facts. Its job is to translate, not to be a judge. Second, pure RAG without a knowledge graph is just searching a haystack. You have to ground it in facts. Third, never store full-text blobs in your graph nodes. It just kills performance. Fourth, always maintain those provenance links back to the source document so you can show your evidence. A huge mistake is querying the vector store before the knowledge graph. Facts must guide your search, not the other way around. And finally, the two cardinal sins, skipping schema validation and having no entity normalization strategy. Avoiding these pitfalls is the absolute key to building a truly trustworthy AI.
So, at the end of the day, it all comes down to this one simple question you should be asking about any AI system you build or you use. Is it built on a foundation of verifiable structured truth, or is it just really sophisticated guesswork? The blueprint we've just walked through gives you the tools to build for truth. The choice is yours.